Imagine enlarging the planet until mountains feel like small hills, and valleys look like shallow cracks. At that scale, some human projects stop looking like infrastructure and start looking like planetary engineering. Entire rivers are redirected. Canyons are crossed in a single leap of steel, and distances that once took days shrink to minutes. In this video, we're diving into the 10 largest mega projects in China. But before we begin, don't forget to like and subscribe to the channel. 10th, Huajiang Grand Canyon Bridge. This project transforms numbers that seem unreal into physical reality. The bridge stretches 7,185 feet in total length, with a main span of 4,659 feet and a deck hanging 2,051 feet above the canyon floor. It is the highest highway bridge in the world and set multiple Guinness World Records upon completion. The structure crosses the immense Huajiang Grand Canyon in Guizhou Province, a natural barrier defined by extreme depth and steep slopes. Before the bridge existed, vehicles were forced to snake along mountain roads, turning a single crossing into a journey of several hours. After opening, the same trip takes just 2 minutes. The greatest obstacle was the terrain itself. There were no stable platforms on either side of the canyon, and building support structures from below was impossible. Traditional construction methods simply did not work here, so engineers effectively moved the construction site into the sky. Thousands of tons of steel trusses were pulled across the canyon using a traction system and assembled more than 2,000 feet above the ground, with deviations controlled down to the millimeter. This technique is used only in the most extreme environments. Construction began in January 2022, and the bridge officially opened to traffic in September 2025, completing the project in under 4 years with a total investment of approximately 2.2 billion yuan, or about $310 million. In global bridge engineering, it is rare to see this level of speed and scale achieved simultaneously. Today, the bridge is more than a transportation route. It was designed as a full tourism destination, featuring observation decks, glass walkways, extreme sports facilities, and a canyon lighting system that will turn it into one of the future icons of mountain tourism. 9th, Beijing Daxing International Airport. If an airport can define a country's transportation capacity, then Beijing Daxing International Airport was designed as a model for future international hubs. Located in southern Beijing, it has a total built area exceeding 15 million square feet. The terminal roof extends outward like a golden starfish. It is one of the largest single-terminal buildings in the world, and also one of the airport projects with the highest operational efficiency under one roof. The construction goal of Daxing Airport is straightforward: relieve congestion at the capital's airport and create a global hub capable of serving the coming decades. To achieve this, minimizing the distance between passengers and boarding gates became the central design principle. No matter where you check in, the walking time to the farthest gate is kept at about 8 minutes. For an airport that serves more than 100 million passengers per year, this is almost physics-defying efficiency. Daxing Airport began construction in 2014 and officially entered operation in 2019, with a total investment exceeding 80 billion yuan. Completing a world-class mega airport in 5 years is a rare speed in modern airport construction history. It is also one of the first hubs in the world to fully adopt a smart airport system, self-service baggage, check-in for completely paperless boarding, AI traffic flow scheduling, and automated baggage sorting. None of this exists as a technology showcase. Everything is designed so passengers do not feel the massive scale inside a giant airport. Its presence changed Beijing's aviation landscape and elevated northern China's air network to a new hub level. 8th, Yangshan Deepwater Port. On the map of the world's ports, Yangshan Deepwater Port emerged in an unconventional way. Other countries deepened their ports. China chose to move an entire port into deep water and build it there. Shanghai is one of the busiest cargo cities in the world. but it has a natural limitation. The mouth of the Yangtze River is shallow, and the larger the ship, the harder it is to dock. As global trade enters the era of mega container ships, any port without deep water will be eliminated by time, no matter how busy it is today. The solution was not to deepen the seabed, but to move the port to the sea. In the Zhoushan archipelago nearby, the water depth meets the draft requirements of the world's largest ships. Engineers therefore chose to reclaim land between the islands, build terminals, and deploy collection and distribution systems, creating a deep-water port area from scratch. To integrate this offshore port with Shanghai, the Donghai Bridge was built, stretching 20.2 miles. This maritime corridor transports equipment, personnel, and cargo flows to and from the port area, integrating Yangshan into Shanghai's port system. The first phase of Yangshan began in 2002 and entered operation in 2005. Since then, it has been continuously expanded, forming the current multi-phase port complex. Among them, Phase 4 is one of the largest fully automated container terminals in the world. Rail-mounted cranes, autonomous AGV vehicles, and sorting systems operate almost entirely automatically, processing global cargo flows with extremely high efficiency. Why invest tens of billions of yuan to build a port at sea? Because it solves a strategic problem. Shanghai's growth is no longer limited by geographic conditions. Deep water brings larger ships, faster turnaround, and more stable global routes, allowing the Port of Shanghai to maintain the world's top ranking in cargo throughput for many consecutive years. 7th, Pinglu Canal. The Pinglu Canal is the first major artificial waterway built in China since the founding of the modern nation. It stretches 83.9 miles, with a total estimated investment of 72.7 billion yuan and an average construction cost of about 500 million yuan per kilometer. The excavation volume is enormous. Engineers describe it as enough earth and rock to fill Three Gorges reservoirs. The canal begins in Hangzhou, Nanning, and ends in Lingshan, Qinzhou, connecting directly to the Beibu Gulf. When completed, it will allow the navigation of 5,000-ton vessels, ending Guangxi's long-standing situation of being close to the sea, but without a direct river-to-sea route. Ships will no longer need to detour through old waterways, reducing the journey by 348 miles and saving about 5.2 billion yuan per year in transportation costs. Its impact goes far beyond Guangxi. As a key project of the new Western Land Sea Corridor, the Pinglu Canal will significantly increase logistics efficiency, bulk cargo transport capacity, and export access for Western China, offering inland regions a faster and more direct maritime route. Construction officially began in August 2022 and is scheduled for completion in 2026. For Guangxi and the entire Western region, this is more than an artificial waterway. It is a strategic project capable of reshaping regional economic dynamics. It will allow bulk goods from the southwest to directly enter international shipping routes. 6th, West-East power transmission. China has a natural contradiction in its energy matrix. Electricity is in the west. Demand is in the east. The west has world-class wind, solar, and hydropower resources, while the east concentrates the largest urban clusters and industrial hubs. If clean energy from the west cannot be delivered efficiently to the east, this enormous energy advantage cannot fully play its role. The West-East Power Transmission Project was created to solve this contradiction. Its core technology is ultra-high voltage transmission. With traditional lines, large amounts of electricity are lost over distances greater than 620 miles. The longer the distance, the greater the loss. The ultra-high voltage solution is to raise the voltage level to the class of millions of volts, allowing power to be transmitted over long distances between provinces with lower losses and greater efficiency. In simple terms, it turns transmitting electricity for thousands of miles into a routine capability. The project is composed of multiple transmission corridors that carry wind power from Xinjiang, solar power from Qinghai, and hydropower from Sichuan and Yunnan to major consumption regions such as the Yangtze River Delta and the Pearl River Delta. The project began in the 2000s, and after more than a decade of construction, China formed the world's largest ultra-high voltage transmission network. Each corridor represents investments of tens of billions of yuan, crossing plateaus, deserts, mountains, and thousands of miles of uninhabited areas. The importance of this project lies not only in long-distance power transmission, but in transforming the energy landscape itself. Fifth, South-North Water Transfer Project. The South-North Water Transfer Project is a water transformation plan that stretches for thousands of miles. It channels water from southern rivers through mountains and plains, finally reaching the dry cities of the north. It is a system that alters geographic patterns and is also the largest interbasin water transfer project in the world. The project is composed of 3 routes: east, central, and west. The core is the central route, which connects the Danjiangkou Reservoir to Beijing and Tianjin. Stretching more than 870 miles, water flows from Hubei to the north, passing through Henan and Hebei until it reaches the North China Plain. The eastern route uses multiple pumping stations to lift water from the Yangtze River northward, following the Beijing-Hangzhou Grand Canal system to supply cities and industries in Jiangsu, Shandong, and other provinces. The western route, still in the planning and feasibility stage, will in the more distant future supplement the upper reaches of the Yellow River, further improving the overall distribution of water resources in northern China. Since its launch in 2002, the project has directly benefited hundreds of millions of people. The meaning of the South-North water transfer is straightforward. It frees the densely populated northern regions from the limitation of natural precipitation, providing a long-term water foundation for urban development, agricultural irrigation, and ecological restoration. Fourth, Sichuan-Tibet Railway. The Sichuan-Tibet Railway is a line that pushes the feasibility of transportation to the limit. It starts in Chengdu and heads west, crossing mountains, geological fault zones, and high-altitude areas along the eastern edge of the Qinghai-Tibet Plateau until it reaches Lhasa. Its construction corridor lies among the most geologically active and topographically dramatic regions on Earth. Stretching more than 995 miles, it must cross dozens of major rivers and countless high mountains and deep valleys. The terrain along the route varies dramatically, with altitudes constantly shifting between plains and plateaus. This makes the Sichuan-Tibet Railway one of the most challenging railway projects in the world. Why is it so difficult? First, geology. The eastern section of the Hengduan Mountains is a highly active tectonic belt with numerous faults, fragile rock layers, and high-intensity seismic zones. The railway must find stable corridors in constantly moving mountains and build a large number of tunnels and bridges to reduce elevation differences and sharp curves along the route. Second, altitude and environment. After Yuexi, the line gradually enters the Qinghai-Tibet Plateau, where hypoxia, severe cold, permafrost, and large daily temperature variations affect construction efficiency and directly test train performance after completion. Third, scale. The route requires the construction of more than 100 tunnels and dozens of major bridges, many located in remote and difficult-to-access valleys. The project has been advancing in sections over many years. The Chengdu-Ya'an section is already in operation, and the Ya'an-Ningqi section is under construction. In the future, when the line is completed, travel time between the two ends will be reduced from dozens of hours to just over 10 hours. For the Sichuan-Tibet region, this railway is not just a rail line, but a new channel for economic development, population mobility, and material transport. Third, Hong Kong-Zhuhai-Macau Bridge. building a bridge over the sea, excavating an undersea tunnel, and then erecting two artificial islands between them. This construction method practically redefined the concept of marine engineering. This corridor crossing the Pearl River estuary stretches 34 miles, connecting Hong Kong, Zhuhai, and Macau. It is not a continuous bridge, but a system composed of bridge plus immersed tunnel plus artificial islands. Its complexity begins with route selection. The Pearl River estuary is the busiest navigation channel in southern China, with large vessels passing daily. If the entire route were a bridge, it would affect navigation. If it were entirely a tunnel, structural and ventilation requirements would be difficult to meet. The chosen solution was to alternate between bridge and tunnel in the middle of the sea, requiring the prior construction of two artificial islands. These islands are not simple landfills. Located in deep water, their foundations rest on layers of soft silt that had to be stabilized with steel cylinders, drainage, and structural reinforcement. Next, immersed tunnel segments weighing tens of thousands of tons were transported to the site and joined with millimeter precision under the influence of tides and currents, forming a 4.2-mile undersea tunnel. This is one of the most challenging immersed tunnel projects in the world. Construction began in 2009 and opened to traffic in 2018, with a total investment exceeding 100 billion yuan. After completion, the overland travel time from Zhuhai to Hong Kong dropped from 3 hours to half an hour, connecting the three cities with a stable maritime corridor for the first time. More importantly, it changed the mobility pattern between the western side of the Pearl River estuary and Hong Kong, driving the reintegration of regional mobility and logistics systems. Second, fast radio telescope in Guizhou. Among the mountains of Guizhou lies a facility that does not look like an engineering structure, yet represents the limit of engineering. It occupies a natural karst depression and has a diameter of 1,640 feet, making it the largest single-dish radio telescope in the world. Its name is FAST, also known as the Eye of the Sky. Its function is simple: to listen to the sounds of the universe. FAST's reflector is composed of more than 4,500 adjustable panels. These panels are continuously reshaped by a cable system, allowing the telescope to point at different regions of the sky. This entire structure must ensure precision on a 1,640-foot scale, with tolerances measured in millimeters. It is a rare combination of astronomy and large-scale mechanical engineering. It was built in Guizhou because the region has some of the densest karst formations in the world. The depressions are deep, the terrain is isolated, and the radio environment is extremely quiet, minimizing human interference. For this purpose, a radio silence zone was established, limiting communication devices to avoid noise in the observation system. FAST began construction in 2011, and its main works were completed in 2016, with a total investment of about 1.1 billion yuan. But what really took time was not the money, but the precision. To give a 1,640-foot telescope millimeter-level shape control capability, every cable, every panel, and every segment of the drive system must achieve extremely high stability. FAST's sensitivity allows it to capture weaker and more distant celestial signals than ever before, making it an essential foundation for global radio astronomy. First, Baihetan Hydropower Station. When the Three Gorges Dam was completed, it seemed unsurpassable. Yet on the Jinsha River in southwestern China, there is a project that takes hydropower conversion to the highest level. This is the Baihetan Hydropower Station, currently the world's largest hydropower plant by generating unit capacity and one of the highest standard projects among similar facilities. It is located in a canyon region on the border between Sichuan and Yunnan. Where the river is fast, the drop is large, and the terrain is complex. This makes it ideal for hydropower generation, but also one of the most challenging sections for construction. The Baihetan Dam is 948 feet tall and is a double-curvature concrete arch dam that must remain stable under enormous long-term water pressure, requiring extremely high structural precision and material performance. The core of the project lies in its generating units. Each unit has a capacity of 1 million kilowatts, the largest hydropower units in the world. The total installed capacity reaches 16 million kilowatts, equivalent to the total electricity consumption of several mid-sized cities. In addition to generating large amounts of power, the plant also performs peak regulation for the regional grid, providing an important energy source for the west-east transmission system. Construction difficulty began from day one. The geological structure of the Jinsha River Canyon is complex, and enormous underground caverns, water diversion tunnels, and energy dissipation structures had to be excavated in confined space. These structures must operate long-term under high-pressure flows and large water drops, imposing strict requirements on engineering precision and equipment manufacturing and installation. The Baihetan hydropower station ranks first on this list, not only because of its size, but because it represents the highest level of contemporary hydropower engineering, building extreme equipment in extreme terrain to provide clean, stable, long-term energy for the lives and industries of hundreds of millions of people. These mega projects span different provinces, terrains, and sectors. Some push into the deep sea, others cut through mountain ranges, and some alter the course of rivers. Their goal has never been simply to build bigger, but to make the country operate more stably, quickly, and efficiently. This is the power of China's mega projects. Thank you for watching. If you enjoy this type of content, remember to like, subscribe, and tell us in the comments which topic you most want to see next.